Alright, hi everyone. Let's continue with our data structures and algorithms series. Previously, we looked at the time complexity of O of n, O of n square, and O of 1. Now, we will look at the time complexity O of log n. But before looking at O of log n, let's try to understand what exactly log is. Log is a shorthand of logarithm, right? And what exactly logarithm is? A logarithm is the inverse of exponentiation. Now to understand this definition, let's look at an example. Here you can see the log of 8 is equals to 3. But how exactly we calculated this value? If you try to observe, there is a 2 at the bottom of log. This is known as our base. And this 8 is our value. Now what exactly we are trying to calculate? What should be the power of this base that will result into this value, right? So if our base is 2 and value is 8, the power of 2 should be 3, right? Because 2 raised to power 3 is equals to 8. Now if you look here, you can see base with raised to exponent is equals to the value, right? This is exponentiation. Now if you look at the log example, we have value 8 with base 2 equals to the exponent, which is inversely proportional. That's why the definition is a logarithm is the inverse of exponentiation, right? Now this base can be anything. It can be 2, it can be 3, it can be 4, or it can be 5. It can be anything. But in our case, the base is going to be 2 in most of the cases. So to simplify it, we are going to use log as shorthand for log with base 2. So in the upcoming videos, if you are going to see log, then consider it log with base 2. But to simplify it, we are going to use log. We will be seeing the time complexity O of log n in most of the common searching and sorting algorithms like binary search and merge sort. But for now, let's look at a simple example that has time complexity O of log n. Alright, so this is the example for O of log n time complexity. So in this example, the function log n example is taking n as parameter. This can be any number. And here we are trying to calculate the power of 2 that will result into n. Basically, we are trying to find out log of n here. If you see, we are having a while loop here with the condition n is greater than 1, which means if n is greater than 1, only then this while loop will work, right? And every time we are trying to divide our n with 2, and we are also maintaining a count variable here that will record how many times we have divided n with 2. Now if we ignore this condition, then we can say the time complexity of this function is O of n, because here we are using a loop, right? And it will run for n number of times, right? But in every step, what we are doing, we are dividing n by 2. We are doing half of it. So if you see, if n is 16, then it will run for only 4 times, right? It's not running for n number of times now. It's running for log n number of times now. You can also verify this by putting this value 16 in our formula which we saw before, right? Which is this base exponent is equals to value. Your base is 2 and your exponent is 4, and it will return 16, right? Which means if we put the same value here in our logarithm formula, log with base 2 and 16, it will be equal to 4, right? Now let's check the time complexity graph once again. Previously we saw that the best time complexity is O of 1, because in this case, if you keep on increasing the input size, it will have no impact on your CPU operations. The CPU operations will remain constant even if you keep on increasing the input size. And we also saw in case of O of n, if you increase the input size, it will increase the CPU operations as well. They are directly proportional in case of O of n. But in case of O of n square or x square, if you increase the input size, it will increase the CPU operations much faster than your input size, which will have a very bad impact on your system, and that's why we should always avoid O of x square or O of n square. But today we saw O of log n, which is much better than O of n and O of x square or O of n square, because it doesn't increase the CPU operations as much as O of n and O of n square. Right, so that's it for today. In the upcoming video, we will see what is space complexity and how we can calculate it with the help of big O notations. Thanks for watching.